So let's take a look at the section 8.2, also dealing with alkenes, of course. But these are looking at some that are naturally occurring and some that are used in industrial ways. Um, but in general, this slide is listing acyclic alkenes. So that means there's no cyclic structures, right? There's no rings involved. So we all are, I'm sure, familiar with this compound, whether you know the name or not. It's that scent, that odor of garlic, which is due to this alkene here. Um, Geraniol over here. This is a more fragrant type of smell that you might want to use in a perfume, not so much the garlic smell. And then we have this other compound down here, which has multiple double bonds within it. But these are all naturally occurring alkenes. We also have some cyclic alkenes that are pointed out in your text. I'm sure we've all heard of cholesterol, right? So we can see that has a double bond there. This limonene, right? We have a couple double bonds in this compound here. And then a bicyclic as well, not just a cyclic, but a bicyclic. We have this pinene. So alkenes can come in various forms. One specific alkene type that I want to point out here is the pheromones that can be found. So these are communication compounds, right, that are used to either for animals or even with plant communication. So things like seaweed, right? We can see these pheromones released from the eggs of seaweed to attract sperm cells, and a variety of insects, right? So we have aphids, we have houseflies, and the codling moth. So alkenes can be found in nature, and they can also be used in industry. So we see on this slide here that we have petroleum, right? So we have these long hydrocarbon chains. They can be broken down, and we can start with ethylene and propylene, so a 2-carbon alkene and a 3-carbon alkene that can produce many products, right? So we initially crack the petroleum, make these smaller molecules, and then from there you can see that our ethylene and our propylene here can form many products, right? So ethylene can eventually be turned into acetic acid, which is vinegar that you might be familiar with, or propylene can be turned into acetone. So again, depending on the starting material and different chemical reactions that occur, alkenes can be very versatile in both the natural world and in industry. And I would note the specific few that are mentioned in these slides.